Okay, today I'm going to do a tutorial for how to use the ultrasonic sensor HCSR04. This is a very popular ultrasonic sensor used in the Arduino. But today I'm going to use this on the STM Nucleo 64. Okay, the board I have is using the Nucleo STM32 L053R8, and this comes with the SD link, so we don't have to buy additional SD link, and we just use the USB connect to our PC. Okay. So let's take a look at this HCSR04. It's a 4-pin. So we have a VCC, of course we have a ground, okay, and then we have a trigger, and then we have a echo. So 4 pins. This is a transmitter, and this is the receiver. So this is using ultrasound. Before we start the programming, I'll brief you on how this ultrasonic sensor works. So this ultrasonic have one transmitter and one receiver. It comes with 4 pins: VCC, 5V, and ground, and we have a trigger pin, and we have an echo pin. This will be connected to our microcontroller. So we have to assign one output pin here and one input. The output from the microcontroller, which we are going to use Nucleo 64, this should be connected to the trigger pin, and the input will be connected to the echo pin. So to start the operation of the ultrasonic sensor, we have to output a pulse of about 10 microseconds to the trigger pin. This to tell the trigger pin to tell the ultrasonic to start measurement. So we have the trigger, and this is about 10 microseconds. Okay. After it start to when the ultrasonic sense detect the 10 microsecond pulse, we'll start to send 8 cycles of 40 kilohertz signal. 40 kilohertz, it's in the range that we human not be able to hear. Our ear can hear around from 20 hertz to 20 kilohertz. Above 20 kilohertz, we are not able to hear the sound. So therefore, it's called the ultrasound. So this sound will be transmitted to the air, and if there's an obstacle, it will bounce back from the obstacle to the receiver. So they are transmitting to the obstacle, so there's a time for transmission. So let's call this time forward, and then this is a time reflected. So this time forward is equals to the time reflected, because this transmitter and receiver are placed very close to each other. So when you transmit and then it meets the obstacle and reflected back, the time taken for both transmit and receive will be the same. So at once it receives at the echo pin, there's after we receive the trigger, there's a pulse. This 40 kilohertz pulse I think there will be about 8 cycles of pulse sent, and it will be about 500 microsecond or later, the echo pin will feedback with a pulse. So this pulse, the high time, the time taken for the high is equals to the transmission time plus the reflected time. Okay, so what we need to do is to measure this time, which is equivalent to the distance traveled by the sound to and fro from the ultrasonic to the obstacle back. So we all know that distance equals to speed times time. Okay, so to find the distance, we use the speed of sound, which is about 343 meter per second, and the time is travel distance t, but this t is both to and from the obstacle. So we are only interested between the time from the ultrasonic sensor to the obstacle. So actually it's only half of it. Okay, so if we because the time is actually in microsecond, we're going to use microsecond to measure the time of travel. So if you convert this to the microsecond, this will be 0.000343 meter per microsecond times t, and then the 2 I'll put below. Okay, and if you are interested in centimeter, so this will be 0.0, move to decimal point, it will be 0.00, okay, so it's only 343 centimeter per microsecond divided by 2 times the time, and this will give you about 0.0343 divided by 2 will give you about 0.01715 times t. So to make the equation looks slightly better, so if we inverse this, will be t divided by 58.3. Okay, so to measure the distance, we just need to measure the echo time, okay, the time of the echo divided by 58.3. So we just need to remember this equation. Okay, now we go back to the programming. We're going to use the STM32 QMX for setting up our peripherals and the clock. So project will access the board selector. Okay, and it's Nucleo 64, and the chip that we're using is STM32 L0, so which is this one, L053R8. So click to start project. Initialize all peripherals with their default mode, yes. Okay, if you look at the Nucleo board, okay, it comes with a low speed oscillator, but it doesn't comes with the high speed crystal here. So we have to remove the pin for the high speed clock in our software. So high speed clock is these two. So we reset state, okay. And we're going to choose two pins, for one for the trigger and one for the echo pin. So let's see D8. So these are the pins that are available on the board. So let's see, let's choose. Okay, I will choose PA9. Okay, PA9 for our trigger and PA8 as our echo. So that when we insert the ultrasonic sensor, the trigger will be plugged into this pin. Okay. Okay, this pin is PA9. Also, if Arduino interface is D8, and this PA8 for the echo, and D7. Okay, so this is echo. I'll connect to the D7, and VCC I will connect to my 5 volt over here. Okay, 5 volt is here. Okay, I hope you can see it's 5 volt. And then the ground, we use ground here. Okay, so the ground is here. Okay, so the connection is done. So again, just now we say we're going to use PA9 as our trigger. So trigger will be output. So we select GPIO output, and we name this as trigger. And PA8 as our echo. So echo will use the interrupt, and we name this as echo. Next we go to GPIO and we look at some more details. So make sure that my trigger is output. Okay, my trigger, we'll leave it as default. But for echo, it's an external interrupt, but we have to detect both the rising and the falling edge. So we have to select the external interrupt mode with rising, falling edge trigger detection. No pull output down needed. Okay, so we go to the interrupt here. We have to enable the interrupt. So for this IC, the interrupt external interrupt line 4 to 15. So we are selecting the PA8 as our interrupt. So actually it's pin 8. So we select yes, enable. We put the low priority, say 1. High priority is 0, low priority is a higher number. Okay, now next we go to the timer. We need a timer to count for in microseconds, so we're going to use the timer tool. The clock source, we use internal. Okay, let me set up the clock first. The clock, we are going to use 32 megahertz because we are going to count in microseconds. So the higher frequency it is, the better it will be. It's just that if you use high frequency, the internal oscillator may not be accurate. But anyway, for our calculation, for ultrasonic measurement, it will now be very precise, so it doesn't matter. So we choose 32, and all change to 32 megahertz. Okay, because if you look at the specs for the L053, the timer tool is using APB1. So if you look at here, APB1 is over here, timer clocks. So set to 32. Then we go back to the timer. We have to set the prescaler. This is 16-bit. 16-bit. So prescaler, if you want to have 1 microsecond, we have to divide the frequency until the frequency at the APB1 is 1 megahertz. 1 megahertz, the period for 1 megahertz is 1 micro. So for this case, we have to, the prescaler is divided by 32 minus 1, because it will count from 0 upwards. Okay, so we have to include the minus 1 there. And then counter period is a full period. Full period, I'm not sure whether we can leave it at 0 or to be safe, I just put a full period, 16 bit. Okay, so I put a full period here. Okay. So what else do we need to set? I think that's all that we need. Okay, and I already created one folder here, and the name we call it, just call it test. And we're going to use MTK ARM because we are using the microvision cam. And we can generate the code. Open project. Okay, so if we browse to our application, application user, and this is our code. So it has been initialized. Okay, but before we can use the timer, we have to initialize it. We have to start. Actually, it has been initialized, but we have to start. We have to start the timer in order to use it. So we're going to put it in the main, but before it starts. So you see here, user could begin. Okay, so we're going to start our timer. Base or underscore base underscore start, and we're going to start the timer 2 for timer 2. Okay, so this will start our timer. Okay, now we need to use interrupt. Our interrupt is used at the echo pin because we need to start counting when you start to have rising edge. So this is a point that we need to start the counting, and this falling edge where we stop the counting, and then we calculate what is the time here. We have to measure the time here. Okay, so we use interrupt to do the measurement. So we go to the interrupt.c. IT is interrupt, and it's interrupt pin 8. See, how do we know it's 8? It's we have to refer back to our QMMX. If you see our pin here, echo pin, this is, you can see from the GPIO underscore external interrupt 8, so it's actually 8. It's not 18. I means interrupt, so this is 8. So that's why I know that it's pin 8. So we look at the interrupt here, and we look for the interrupt handler. So external interrupt pin 4 to pin 15 all will be caught in this RRQ handler. And then if we go to the individual, if let's say it's the pin 8, what will it do? So let's take a look at the definition for the external interrupt RRQ handler. Oh yeah, because we need to compile once, then we can shortcut go to the function. Okay, let's go to the definition of the external interrupt RRQ handler. And yeah, here. So it says that if the interrupt pin equals to this, not equals to reset, okay, that means it's raised. Then you will go clear it first, clear the interrupt flag, and then you go to here. So this is a callback. Go to the definition of the callback, and you see that this function is a weak function, which means that we can override. We can override the function. So what we can do is go to the main, and we scroll down to the user code here. So we can create the function to override the existing callback. So it goes to here instead of go to the whole GPIO.c. So what should we do inside so the first thing is that we have to check whether is it a rising edge or falling edge. So we check once it was interrupt. So we need to check whether the pin. So we go to whole GPIO. We use the library, the whole library, which is easier to use. Read pin. Which pin? We have to read the echo pin. So first we select the port. Okay, then we select pin. Okay, first we check whether is it a rising edge. Else it will be a falling edge. I forgot to close bracket. Okay, so if it is a rising edge, then we need to start to count. And we can use a variable. Let's call it echo counter start. Okay, equals to we have to get the counter from the timer 2 in microsecond. So underscore timer get counter. It's a 16-bit counter, so you count from 0 all the way to FFFF. So which timer? Or timer 2. Okay, this one we have to define the variable yet, so we have to define it as let's use 32-bit integer. So we define in the global variables. User, we put it under the user begin private variables. unsigned 32-bit integer, let's go T. Okay, and then so if it is rising edge, we start to count. We start to get the initial values. So if we detect the falling edge, which means that it's reaching the end of the return time, we have to stop counting. But we don't have to stop counting, but we have to measure or calculate what is the time taken from the rising edge to the falling edge. So we can use another variable. Let's call this echo time. Equals to, we get the counter from the timer, and we minus the start. Okay, so we haven't defined the variable yet, so we're going to define it now. I'm going to put below the echo counter. So again, I'm using the same type 32-bit unsigned integer. Okay. Okay, so we are now able to count from the rising edge to the falling edge using the interrupt. Okay, then we have to define another, because we need to start the ultrasonic measurement. We need to send a 10 microsecond pulse to the trigger. So we have to create a function for delay, a microsecond delay. Because the default Hall delay is using the SysTick, which is per tick is 1 millisecond. So we're going to use the timer 2 again, which ticks at 1 microsecond. So we're going to define another delay functions for the microsecond. So we call this delay microsecond, and we have to input, let's say, okay, just assign integer 32. Delay, require delay. So we put below the callback function. Let's call this tick start. So we're calling the counter from the timer 2 again. From Hall timer 2. Okay. Okay. Put a while loop here so that if the counter does not exceed the delay, it will keep looping in the while loop. Okay, So if not, then you come out. So this is by microsecond, the delay in microsecond. Okay, let me see. So now I go back to the main. In the while one, so what I'm going to do is, I think we got to use the button. We got to use the button, the blue button on the Nucleo board. Okay, so this is the button. When we press the button, then you start measurement. So each time one press will do calculation for one measurement. So user code begin 3. So we start here. So if we have to read the for GPIO read pin, we're reading this button, which is B1 GPIO port and B1 pin. So if it is a low, means it's pressed. We'll put some delay here, maybe like how about 100 milliseconds. This for the debouncing delay. And okay, when I press, it will not start. Only when I release. When I release the button, then it will start to count. Okay, so I put another while loop here. Okay. So we continue to read the GPIO pin of the button. So if it is low, it will start here. Until when you release. Okay, until when you release, then missing one. Yeah, missing one bracket. So until when you release, then it start to do the rest. So I think I will also have another delay for debouncing. May or may not be needed, just to be safe. So another 100 millisecond delay, just for debouncing. Okay. After the release of the button, then we'll do the trigger pulse. So for GPIO right pin. So we go to right pin to the trigger port. And trigger pin, GPIO pin set. So this will pull high the trigger pin. And then we have a 10 microsecond delay. And then we preload. So it becomes a pulse. Display trigger, port, trigger, pin. Okay, so this is to cater for the button press. Once I press, then I start to send a pulse of 10 microseconds to the trigger pin. And when it stands to the trigger pin, the ultrasound sensor will start to send the ultrasound pulse through the transmitter and receive at the receiver, and the microcontroller will able to pick up the pulse from the echo pin via the interrupt. Okay, once it once the echo pin once at okay, once the echo pin once the echo pin is falling edge, you compute the echo time, the received echo time. So there will be some values for the echo time, it will not be 0 anymore. So at the above, when we define echo time, we have to make it equals to 0. So when over here, you have to make a statement if echo time is not equals to 0. Oh, sorry. If echo time is there's some value at the echo time, then we'll do something here. So what I'm going to do, we go to echo time equals to 0. We have to reset the value, but before resetting, we have to calculate the distance. Just like I mentioned, the distance equation is distance equals to speed of. We go back to the distance equals to time divided by 58.3. Okay, so equals to the time, the echo time divided by 58.3. Okay, the distance itself will be a floating variable. So we go to the top. Okay. Okay, that's about it. Let's try out the codes. Okay, no errors. Now I'm getting ST device on board connection. Okay, this happens a lot of time. What we need to do is go to the project. Under the option, we have to go to the debug and the settings for the debug and choose pre-reset. Click OK. Okay, save, compile again, and then now you can download. I use the debug so that you can see what's the value of the distance in real time. I'm gonna make this, close it. So what we want to see is the value of the distance. So add this to the watch. Yeah, reset and 1. Okay, so every time I press a button, it will show me some values here. Okay, let me turn on the camera. Okay, this is a button. This is my ultrasound sensor, so I place it at the angle so you can see more clearly, and I put a piece of paper here for this measurement. Okay, this distance is about, let's see the oh dear. Okay, let's put it about 10 cm away. Okay. So show whether I can see clearly. Put closer. So distance from the cardboard. okay, to my ultrasonic sensor. It's about it's about 10 minutes. This is 100 millimeter, which is 10 cm. Okay, you can see from here. Okay, so this is the distance from my ultrasonic transmitter to the cupboard. Not sure where you can see, you know. Okay, about there, about there. Okay, so hopefully it will show me about 100 over here. So now I press the button. Yeah, so you can see that now it's a 9.6 cm. Remember, the calculation is based on centimeter. Press again. Okay, so still show me about the same, so which is quite accurate. So when I move closer to here, I think that this distance is about 5 to 6 centimeter. Yeah, so it's about 5. Okay, so I move to 10 centimeter, about here, and I get, okay, slightly further away. Yeah, about 10 centimeters. So that reading is pretty accurate. Okay, so that's it for this tutorial. Hopefully you can understand what I'm trying to do. Okay, see you again in another video.